Hi, my name is Vignesh Nathan, and I'm an applications engineer with Keysight Technologies. In this video, I'm going to show you how to make a waveform delay measurements on an InfiniiVision-X series oscilloscope, and the particular model that I'm using in this video is the 2000X series model. So at the end of this video, we're going to align the sine waves on channel 1 and 3. We're going to use cursors to measure the edge difference, and we're also going to use the skew feature on channel 3 to align the waveforms and remove the cable delays. And finally, the acquisition mode of the oscilloscope was set to averaging so that we get a very clean signal and we can see the edge clearly. The source of the sine waves are this 81160A arbitrary waveform generator, and the sine waves are set to 200 MHz. I can change the delay of the channel 2 on this waveform generator, and we'll see how small of a delay the oscilloscope can detect. I think with the setup that we had, 50 or 60 picoseconds is the error. So delay smaller than that is something the oscilloscope will not be able to see. Alright, so I'm going to show you the navigation of the buttons and the menu on the oscilloscope using this front panel, remote front panel view. So when you hit the channel menu, hit probe, the skew value which we will use in this video, it can only be removed if you hit factory default. So let's go ahead and do that. Alright, now I'm going to hit auto scale to bring the two waveforms on the screen. And I'm going to set both of them to 2 volts per division. Okay, now that they're roughly the same, let's turn on averaging acquisition. That way we reduce the amount of noise on the signal. You're going to go ahead and turn up the averages to 1024. Okay, great. So as you can see, the time base is minimal for this oscilloscope, which is 2 nanoseconds per division. It's a pretty fast waveform, so you kind of have to zoom in to see the edges. Right, so now as you can see, channel 3 has a little bit of skew compared to channel 1. So we need to correct for that. And channel 1 has also a slight delay in terms of triggering here. So let me try to set channel 1 to be in the middle graticule. So you want to make sure the trigger is set to edge, channel 1. And I'm going to try to change the levels here. Okay, so the trigger level is right in the middle graticule. I'm going to use the offset to bring channel 1 to the middle. Okay, that looks great. So now let's go to channel 3. This is the channel 3 menu. Press probe, go to the skew, and we want to change the skew value so that the channel 3 edge sits right on top of channel 1. And that removes the cable delay difference between channel 1 and 3. So I believe that is pretty much right on top of each other. So now press the measure button, clear all the measurements, go to the measurement type and scroll down to delay. So you want to make sure the source of the measurement is one is channel 1 and the other one is channel 3. So add that measurement. So as you can see, the skew that we put in still is not good enough, so let's try and fix that. Looks like there's a positive delay of 30 picoseconds here, so let's try to remove that. Okay, so we get a delay down to 0. So this would be the absolute starting point to make the delay measurements between the waveform. Now we can go to the waveform generator and dial in a delay and see what is the smallest, most accurate delay that this oscilloscope can measure. With this oscilloscope, I've currently dialed the waveform generator delay to be 100 picoseconds, but I'm getting 90 to 130 picoseconds, which means that the error is about 30 to 40 picoseconds. That's pretty good because when I dialed the 1 nanosecond, it actually turned out accurate. So that would be the limitation for this oscilloscope. For the 3000X, you can quantify this error a little bit better, because when you go to the measurements, you can add the statistics of the measurement. Anyways, this is a quick video on using the skew, using averaging, and using the delay measurement on InfiniiVision-X oscilloscopes to find the phase delay between or the phase delay or time delay between two waveforms. Thank you for watching.